check。嗯，对。check。哎，对。嗯嗯。check。哎，对。老师，这个直播间已经一切正常了，待会直接开始就可以了。
好，谢谢。那我带我的登记点，好吧。Hello, morning. We can wait for 3 or 5 minutes, then we can get started. All right, since the meetup is on live, so we can go through our check with our monthly progress. Then, if you're interested, you can watch the video later. So let's get started. So from the last month, we let's first share with our the current status, then go through some planned milestones in the coming months, and then we quickly go through the brief of the change of the last monthly release. Then it's expected to be take around 30 minutes. And then if any questions, we can answer question one by one. So let's first go through the status. So as you can see, let me share my screen. Yeah. Cool. So okay. So I suppose you should see the I suppose you should see the screen. So so over the last month, we grew around 300 users on the marketplace, which is the best code, and around 10,000 users on the Open Basic. The exciting news is our package number is still growing very fast. We have more than 4,000 new packages. So we have month to month 30% or 20 to 30% for around half a year. So we grew 10 times in the last 12 months. And so yeah, so given the language is prior to 1.0, I think it's a pretty exciting number. And the two scenarios I will focus on is first is we aim to make MoonBit the ideal language to use by agents. Actually, I think the MoonBit is designed to be quite fit for the agents. First, we have on day one, we optimize to compile the MoonBit to the WebAssembly, which is a sandbox native, which means you have very fine-grained permission model. You can, and even better because you can compile MoonBit to a WebAssembly module and then give the capability-based permission, and internally you will call another MoonBit binaries, which is also compiled to the WebAssembly. Then it can be recursively inherent your policy. We're going to publish an article on how to use MoonBit safely with the sandbox. So the cool thing with the sandbox is most sandbox has to sacrifice the user experience for safety. But with MoonBit, you don't need to make a big compromise on the user experience. You can still have a very good user experience while maintain the safety. And another thing I think MoonBit is very fit for the agent it is also because we compile the WebAssembly. You have the cross-platform distribution. Actually, this is quite important these days. Most dev tools doesn't work very well on Windows, but if you just use MoonBit as a script language for Windows, then you get all the cross-platform user experience. And as an example, we rewrote the Office CLI in MoonBit. It's a large repo. I think it's around 70,000 line code, but we compile the whole Office agentic CLI into only 3 to 4 megabytes, and it works anywhere. And you can use this library or CLI to automate your Office experience. As we said, we are going to open source the Sigmoon, the agent. We build all the full stack in MoonBit. The UI, the agent, and the IDE all in MoonBit. We plan to really open source the Sigmoon, the agent. Actually, it works very well with the open source models plus MoonBit. This is quite exciting given the MoonBit is relatively very new language and there's not too many data in the open source models, but it already works pretty well. At the same time, we're going to open source the Moon Desktop. So it's a cross-platform desktop UI. So you can use MoonBit to build the cross-platform for UI. And because MoonBit compiled to both the JavaScript and because we compile to both JavaScript and native, so same language, you can write both the front end and backend, and it's even better than JavaScript because now you have the safe type definition. I can share the same code. Yes, that's the thing I'm very excited about, and we are moving close to 1.0. So probably we are going to have the first RC release in September. Then we aim to make it production ready in November. So we have 2 months to fix bugs, to clean up the API. Yeah, so we are very close to 1.0. And there were some large major break change coming prior to 1.0. I think the first is actually quite exciting because we are going to have the cancellation as an effect. Because MoonBit support the static concurrency like the Swift or Kotlin, but there's a footnote here because if you use Kotlin, you will find if you try to catch any exception, then we'll try to catch the cancellation. This is actually not what you want. So in MoonBit, we have to annotate the function as a cancel, no cancel. So you have the static guarantee, and you try catch will not catch the cancellation. I think it's a good change, and it improves the reliability of your async style code. And another break change, actually I mentioned multiple times before, is we are going to have a implicit promotion from trace method to the time method. This is already announced before, but it's not turned on. But we are going to turn it on soon. So maybe you will hit a lot of warnings. So, but thanks to AI, I think AI can help you fix a lot of warnings. Okay, so this is pretty much the big picture. Now let's go through our updates for the last month. Cool. So the first one is a tiny cosmetic change just to tweak your syntax to support the width pattern. But the feature is already there in the last 2 release. Another thing is we support pattern match for the V128, V128. This is pretty exciting because now you can pattern match you have the bit pattern to do the SMD. Just use the pattern match. Yeah, but the feature itself is straightforward. And as we said, because we want MoonBit to be an ideal language for the agent, so we want to it's very easy for the data processing, for the stream processing. So we have the built-in reject spot in last release. So you can, this is pretty much like AWK, but it's more static and more type safe. So you can just like scan your input with a bunch of regex expressions, and you can continue to scan. It's very convenient, and you can and support the async I/O and the sync I/O and the stream. So yeah, so it works pretty much for very easy for the data processing, and combined with our scripting mode. So MoonBit is, in my opinion, a very good language for the scripting without losing performance and correctness. Cool. So yeah, so because we are going to have a cancellation as a effect, we are adding some new feature like error depth. So if you this is very similar to the Zig's error depth. So if you have a if you open some file channel, you want to protect the channel to be released. If you happen to hit error, you can just add an error depth. So yeah, so you don't need to track cache anymore. So you just use the error depth for the resource cleanup when it's the hidden error. So error depth is different from defer because the defer is only triggered in all paths, but error defer only triggered when the error is hit. Cool. Yeah. So and then we generalize the defer and error defer to make it support both the error function and the async function to make it more useful. Because now we encourage people to use the error defer and the defer. So if you accidentally use the try catch pattern, which is semantic will be changed because of the cancellation support. So we are encouraging you to migrate to error defer. In this case. And the next item is we have the guard. Previously, the guard is an expression pattern, and we have implicit say, oh, we a bot. But now it's more explicit. You have to add a guard bound to say, oh, if the pattern is not exhaustive, then you hit a bot exception. Yeah, and then if the pattern is truly exhaustive, then you get no error. So this makes the code more explicit and robust. Another thing, a tiny feature I think is we added a label block, so you can break a label block. But for the block which has no labels, you cannot break or continue. This feature is most useful for the macro, for when you do some source level program transformation. You want to make it break the labels, then this is so. For example, you want to do some DFA static code generation. You probably want to use it. And yeah. So actually, this is more safe compared with the traditional the block label because you have to give an explicit label, and inside the explicit label block, if you write a break without labels, then you hit a compile error to ask you to add the label to make the code more readable. Yeah. So no cancel is something I mentioned. It's we are going to have a cancellation and a first class effect. Cool. So the next item is some bug fix. So the warnings works on previous warning doesn't work on syntax warning. Now it also works. So yeah. So you can explicitly turn off some warnings for the syntax warnings, give you more fine-grained control permission. Okay. So the tool chain updates is we migrate from the default target from the Wasm GC to Wasm because we found Wasm is pretty much Wasm. The Wasm GC only works well on the browser, but Wasm the Wasm 1 works good everywhere. So and it also supports our async I/O model, so it's generally more useful. And we improve the Moonproof toolchain so you can have so the installation is better, and especially for the Windows users. Cool. So next one actually quite big is MoonX. MoonX is an ideal way to distribute software. So now if you release your open source package onto the moonkit.io with and then if you have a Wasm backend, I mean if we explicitly declare it support the Wasm backend, then we'll build the Wasm for you. Then you can just MoonX the executable, then you have the cross-platform CLI at your hand. This is quite. This is from the user experience view. This is similar to the NPX, but it's quite different because we preview the Watson binary for you. So you are basically just downloading the binary, and it's because it compiles Watson, so it's more safe, and it's fast. So and it's really easy to deploy your binaries. So yeah, I really like it. We also added support for the .moon ignore. This is also very close to the .npm ignore. So you can just have if you want to publish a package, but you want to ignore some files, you can add the reject expression to which file you want to ignore. Yeah, so hi. So you're welcome to ask me any question if you have any question about MoonBit and the future plan. Yeah, so otherwise I can continue to explain the new features and yeah, about the MoonBit. Cool. Yeah, so the monkey is very close to the .npm ignore, so you can ignore your files, as I said. Cool. So the next one is a slightly bug fix because some operating system is case insensitive. So we also, and then you happen to have some two names which is all in case different. So we cause some trouble, but now we do a normalization to make sure everything goes well. So for standard library, actually we have some interesting stuff. Is the first one we try to, and we managed to bring a quick check into the core library. This is because these days a lot of code are AI generated. So we want to make sure the user can write some high-level specs test to find bugs in the AI generated code and to improve the reliability. For people who are not familiar with the quick check is more like the random testing. So you write some property, and then the type system compiler will synthesize the data for you to fuzzing your algorithm to find some edge case or some if you find some failed examples, then you try to shrink the failed examples to give you a small counter example to help you fix the bugs. So actually, we use it in our core library, and we found some bugs in our core library. So hopefully, I think everyone should use quick check to test your AI generated code to improve your reliability of your library. Cool. And we also add a new package called diff package because we think diff is really important, and we are going to open source our MoonBit MoonBit native AI, and you have different diff views. So you can have your tokenized diff views, AST-based diff views. So things quite useful. So we also add a diff package, so you can use in your library if you need it. And the other package, LexPath, as I said, is for the lexicon, because we can use the MoonBit, as I said before. MoonBit has a AWK style reject support. So you can basically scan the IO stream using the reject expression. So this is a runtime support for our lexicon. Cool. The immutable array is difficult for a long time, so we remove it. So if you want to use the immutable array, you are encouraged to use the immutable vector, which is well tested and yeah, and has better performance. So for async, we have a lot of bug fix and the performance improvement. And I think the next big thing is we are going to move the async package into the core. So yeah, we have the async IO just in the core without installing a new package or new module. Yeah. So, and I said, so I think also is going to have if we miss it, we are going to have the async, our async, the structured concurrency library. We are going to have the first class support for the cancellation, and the cancellation will be effect. So it will be static typed. So unlike the Kotlin, because if you know structured concurrency and know Kotlin, when you try to catch a exception, then you catch the cancellation. So in MoonBit, it's no longer the case. You can just declare the effect called no cancel or cancel. Then you will get the static guarantee, unlike the Kotlin. Cool. Yeah, I think there's a lot of change going on in the async library. As I said, we are going to move in when it's ready. We're going to move it to the core library, so we not go through one by one. Cool. So this is pretty much the thing we have the in the last month release. So I will have a new user coming. So if you have any question, I'm very happy to take any question. Yeah. So we are going to, as I said, we are going to have our 1.0 RC release in September. This is on the plan, and probably will hit the formally 1.0 release in November. So that's our current plan. Yeah. Any question from online? If no question, we'll stop here. So how do I say your name? Long Train. Do you have any question? Welcome. Yeah.
Lachlan. Yeah.
Cool.
Yeah. I was interested in the changes you were talking about for the cancellation.
Yeah. So for new language like the Swift and the Kotlin, they have the structured concurrency, right? This is the same with the MoonBit. We also have the structured concurrency, but there's a foregone in the Kotlin is when you try to do the try catch the exception, and you will catch the cancellation. So actually, this is not what you want. So we move the cancellation as a static effect. So for the async, you will declare the async by default. Async effect means it will have a raise effect. We will have the cancel effect. But you can also declare the async as a no cancel. So then in this case, it's no cancel effect. And then in the try catch will no longer catch the cancellation. So the cancellation no longer is an exception. So the thing is we find it really easy to make a mistake because people really like to try to catch everything. Then we try to catch the cancellation. That's
right, because you usually don't want to catch the cancellation.
Yes. That's the.
But you still could catch it if you had a reason to want to catch it.
Oh, so yeah, if you really, if you really want to try to catch everything, then you can. We have a dedicated primitive to catch the cancellation. We have we have dedicated a function to catch the cancellation. Yeah.
Okay. Yeah, sounds great.
Cool. Any question or otherwise cool.
No, that's all I could think of.
All right, thank you for being here, and have a good day. Yeah.
Yeah, you too.
Bye.
I'll see you. Bye.
See you.